Now, before we get into the details, I first want to talk about the ion channels that are present within the membrane of the cardiac myocytes, and they are responsible for the action potential. And we'll begin by talking about the sodium channels. Now, these sodium channels are called the fast voltage-gated sodium channels. They're called fast because they are very quick to open and they are very quick to close, and hence they remain open for a very brief period of time, about 10,000ths of a second. Now, these channels, when they open, they allow the movement of ions from the outside of the cell to the inside of the cell. And so they allow for sodium influx. And so influx just means the movement of ions towards the cell, to the inside of the cell. And so this direction of flow of sodium ions is because of the high concentration of gradient of sodium ions in the extracellular space relative to that to the inside of the cell. So there's a lower concentration of sodium inside of the cell. And as you know, ions like to flow from areas of high concentration to areas of low concentration. Now, these sodium channels are the first to open in the myocyte action potential and are responsible for phase 0 of the action potential, which is also called the phase of rapid depolarization. We'll talk more about that. Now, as you know, depolarization just means the membrane potential rises and becomes more positive. And in here, it's because positive sodium ions are flowing to the cell and making it more positive. Now, these sodium channels are very similar to those that are found within the skeletal muscles. Now, let's review what I've said so far. These channels are called the fast sodium channels. They're very quick to open, they are very quick to close, and they remain open for a brief period of time. And during that period, a huge amount of sodium ions flow to the inside of the cell, causing the cell to become more positive and hence depolarize. And these channels are responsible for phase 0 of the myocyte action potential, and we'll talk about more in a second. And these channels are similar to those found with the skeletal muscles.